All right, so it's been a little while, but I am feeling better. I was sick for a little while and I had to deal with some school stuff. So, took a little bit of a break, only a few days, I think like 2 days, 3 days. So we're going to go ahead and if you're watching the playlist, then hopefully it's pretty continuous. So here what we have is an example using relative velocity addition. And it says 2 rockets leave their space station along a perpendicular path. So like boom, boom. It's a 90-degree angle. Rocket 1, which we're calling to be this rocket, goes at 60% the speed of light. 60% the speed of light. And rocket 2 goes 80% the speed of light. 80% the speed of light. Notice that it doesn't go in the x direction at all, only in the y. What is the velocity of the rocket 2 as observed by rocket 1? Okay, so let's go ahead and talk about how we would do this traditionally, like with Galilean kind of physics. Well, we would say velocity is the square root of vx squared plus vy squared. So in this case, what's the x? Well, it'll be negative 0.6 c squared plus 0.80 c squared. And if you plug that in, you'll get a relative velocity of c. Now, let's see what we get when we use our new information. Well, we know that there's no velocity in the x direction, but let's go ahead and work it out. So v prime x is equal to vx minus u over 1 minus vx u over c squared. So rocket 2 itself doesn't have any velocity in the x direction. But notice from the perspective of rocket 2, it looks like it's moving to the left at negative 60% the speed of light, because that's how fast rocket 1 is moving. So we can say v prime x equals, what is this? 0 minus u all over 1 minus 0 u c squared. Multiplying by 0, that's just 0. So it's just negative u, which is what we expected, right? So just negative 0.60 c. Let's look at v prime y. That's the one we derived in the previous video in this section. And we showed that that was vy times the square root of 1 minus u squared over c squared all over 1 minus vxu over c squared. And if we plugged in our values, what do we get? 0.80 c times the square root of 1 minus, this is 0.60 squared, all over 1 minus, and that's just 0. Now, if you plug this in, which I did earlier, you'll just have to trust me here. You can plug it in yourself, I guess. You don't really have to trust me. You'll get 0.88 c. So instead of going the speed of light, what's actually observed is, first off, this is in the y direction. To find our actual velocity, we would say velocity is the square root of vx squared prime, vy prime squared prime. This is the magnitude. But now we have different numbers. That's the big difference between what we did earlier and what we're going to do now. The fact that we have different numbers is going to obviously change this. So what did we say this was? Negative 0.6, negative, but it's being squared, so it doesn't really matter. Plus, now we're saying that this is 0.88c squared. Okay, so if you plug that in, I'm sorry, I jumped ahead of myself. This is 0.64c. And then the answer ends up being 0.88c. There we go. So jumped the gun there a little bit. I had the numbers written down and I saw one and I'm like, okay, that must be it, but got it backwards. Right? Yeah. Okay. So this is our velocity in the y direction from the other observer. And that's what we plug into here. Compared to above, where you just get c. And that is right. Okay, so hopefully that makes sense. This was a good little easy example. Hopefully that makes sense, and we'll try to keep doing more of these.